Purpose of physics. That's that's where you started, huh?
Well, yeah, we
You
could
gotta
do.
start off with the purpose of physics. I mean, I finally get why you talk so much about like the rules
Yeah,
or
it's
or,
like you need
or
to establish some of
what's
these things.
irrational. I mean, you started this whole thing with irrational, trying to find irrational, but it goes deeper and deeper and deeper, where it goes down to what is the purpose of physics in the first place? Like,
Yeah.
what are we doing here?
What are we?
What are we doing?
Why did we come?
And it's weird that you wouldn't start with that. You think that's physics 101, but that's physics 303 or something. That's the last class of physics. Is what have we been doing this whole time?
Yeah. What do these guys? I mean, you talked about, what do physicists do for a living?
Yeah.
I mean, a lot of people must have that question out there. What do they do for a living? It's one
What
of
do they
those.
do all day?
Yeah, yeah. And you wonder really about it, don't you? Okay,
What
so
is physics?
let's get on with it.
Does the same rule apply to biology and things, and like chemistry, where they're just trying to explain things, or is it more of a tool?
Biology. I think it applies to everything.
Yeah, but is
Hello, everyone. I'm here debating for. We've been debating for an hour now. I don't think we can talk anymore.
yeah, we
um,
started early this time.
we started very early because we've been trying to figure out what we've been doing for the last 2 weeks. And because Ans says, we haven't. Ans, by the way, he's on the other side here.
Hi guys.
Maybe you should always show your face before.
I want to stand over. Hi guys.
Okay, there he is. What we've been doing for the last 2 weeks, and I told him, well, we've been trying to get to the foundations of physics, or science first and physics later. You can include philosophy there as a separate branch. And he says, but we haven't been doing physics. And I said, well, yes, you're right. We don't do physics. What we're trying to figure out is, what is physics about? Because maybe we're all wasting our time. And a good question pops up is, what are all these people at Harvard and Cambridge and all these other universities? What do they do for a living? I mean, what do they do every day? They just put equations on the board, and I mean, that's what they make those big bucks for. Just putting stuff that maybe has no relevance whatsoever.
I like
What
that
is
word.
physics?
I like that word, relevance, because that
Yeah,
goes to the heart of the issue. What is relevant in physics? What is the purpose of physics? What's the point?
right.
What?
You
What?
start with purpose. What is the purpose of physics? And then you try to lay the
But
foundations,
then,
and among those foundations are, the definitions of the key words that you're going to need to do physics.
but then the
Yeah.
critical question there is what is what do we call physics? That's the right question. At what point when someone's talking do you say, "Oh, he's doing physics"? That's the right question. That's the right way to conceptualize
Is
the issue.
that
When
giving us
you
the purpose of?
it's what do we call it's essentially the definition of physics. You can think of it something like that, where
Uh,
if you have someone teaching a little kid how magnets work, you'd say, "Oh, he's doing physics right now," right? But if
and one of the ways to arrive at that definition is by brainstorming, just a series of
mm-hmm.
examples that say, was this physics? Is this physics? Is this
Yeah,
physics? And then once you have all those examples, say, okay, now we know we have a general idea of what we're going to incorporate within what we call physics. And then somehow you define the term so that you encompass all these examples, or
mm-hmm.
as many as possible, hopefully all of them. And then at that point, you say, okay, then let's start now defining physics, and let's define the words necessary to do physics. And this came about because we were debating about an hour ago. You go to a conference, and you have to establish perhaps the rules of debate. And you're saying, well, what do we mean by the rules? Are we just a debate? Are we only referring to how to carry out a debate? Like if you've seen a couple of debates out there on YouTube, and they'll show that one person stands up and he gives his presentation. Maybe he gets 15 minutes to make his case. He sits down, the other person comes up, he talks for 15 minutes. Then the first person again goes up there and criticizes the first person, or says, what he thinks about what this guy said. He sits down. The other guy has 2 to 3, 4, 5 minutes to criticize the other
It
guy.
usually works. It
It's
usually works like answer question. Where I answer your question,
Yeah.
then I give you a question, then you answer my question, then you give me a question.
Okay, but that's the format.
Hmm.
But then the other issue is, what is the subject matter? I mean, if we're going to say physics, well, what are we discussing? Shouldn't
Yeah.
we define what physics is? And this comes about, again, this fellow that I talked about yesterday, Ivor Cat, and his notion of physics is something totally different than what is physics to me. I mean, the way he looks at it, physics is about equations, measuring, running experiments, testing their hypothesis, making predictions, all this kind of stuff. And I'm saying none of that is physics. I don't know what you're talking about, but that's not physics. Physics is, tell me how a magnet attracts another. Is that part of physics? Tell me why a pin falls to the floor, not to the ceiling. Is that, an example of physics? Explaining phenomena. That's what I always had in mind is physics, just natural to me, and that kind of contrasts with what these people are saying.
But then there's a bigger issue there, which is everyone has a different thing that they point to when they think of physics.
But is it brainwashing?
For example, when I gave the example earlier of the guy teaching the little kid how magnets work, you and
Okay.
I would call that physics, but maybe someone else wouldn't. So doesn't it go to the notion of physics or the notion of teaching maybe? Maybe physics is the wrong word to put a loop over. Maybe the real word is the purpose of physics, which is teaching.
Science is explaining, which would be teaching.
Which would be teaching.
But then,
And I think everyone.
but then hold it.
Yeah.
And then what I'm saying is physics is explaining, because it's a branch of science, so you must explain a theory, but in which you use objects and you're going to explain a mechanism and a cause. Versus philosophy, which you explain a purpose and a reason, and you use concepts. That's how I divide these two, to make them clear cut, black and white kind of thing.
But maybe that's the issue of teaching, right? That's a more precise word
For science.
For when you're debating, for example, the person you were debating with recently
Uh-huh.
about what is physics, right?
Yeah.
Something you can probably both agree on is understanding and teaching is the purpose of physics. Would it be something along the lines of teaching or understanding and teaching?
I'm saying that it's got to do with neither. I'm saying it's got to do with explaining.
But
And that's kind of a in between teaching and understanding. It's like,
okay.
I'm going to explain whether you learned, you understood, whether you.
No. But what I was saying is, I think that's how you define it. But
Yeah.
But if someone were to come to a science conference and say, okay, what we're all here to do is to understand and teach, you would also raise your hand. You'd be like, yeah, that sounds like what we're here to do. I don't think there's a single scientist that would come to a conference and someone says, look, we're all here to understand and teach.
Uh-huh.
And I think everyone would raise their hand that that's the whole reason they're there.
And I'm saying that's not the case. I'm saying that
What is explaining then? If it has nothing to do with understanding and teaching?
Yeah, because I can't vouch for what another person understands. If I talk to a crowd of people who have Down syndrome,
But you're teaching.
they won't understand. And I'm not really teaching. I'm trying to explain how a car works. You can say that you're teaching. I'm not teaching in the sense that, because teaching involves also the fact that the other person makes some progress. There's teaching includes the student, right?
True.
And here we're not concerned about the student. We're concerned about the theory. We're saying, how does this work? Or, what is the mechanism here? And so you just explain the mechanism and you leave. That's it. You just objectively put it out there.
Yeah, but see, you're wrong there because
okay.
That's the problem. When you
I'm
say,
wrong.
I guess that's the question.
No
Why?
supper, no supper for him.
What is the purpose of explaining?
Purpose is explaining is trying to
Get them to understand.
figure.
Say it. Say it.
Purpose of explaining to making sense of the universe, Mother Nature's shop.
I think the ending. I mean, we just before we started the thing, we had a powwow about the word understand and many things, but one among which was the word understanding. where we had a difference between understanding and visualizing. But in the
Yeah.
broadest sense of the term, I think physics is all about understanding. You understanding, you passing on that understanding, we'll call that teaching. It's all about understanding the mechanisms of the universe.
Yeah, but see, I disagree there because,
Maybe visualizing is the right word.
and we got into that. Let's clarify a couple things here. Hans was saying the following. He says, what is physics? And we got to two words that are better than the word understanding. And it has to do with saying that physics, you visualize. Physics is literal. Why is it literal? Because of what Tom said the other day. He says, you have an object and you make a movie of your theory, and you should be able to visualize, see, or watch the movie and understand the mechanism or cause being proposed. And that differs from understanding, which is, like a computer doesn't visualize. Computer understands the instructions you give it. You give it instructions, just follows the instruction, and in that sense, it understands.
It's logic.
It's just logic. It just follows whatever you put in there, garbage in, garbage out. On the other hand, physics is, I'm just going to put some objects on the screen, I'm going to put them in motion, and just by watching, you should understand. You should understand. You should visualize. Yeah, it's so easy to get fooled.
Yeah.
You should visualize. You should make an impression in your mind of what the mechanism is. And we use the word understand, but really it's not understanding. It's visualizing.
Understanding is too broad a word
Right.
to use in this. When you get to the nitty gritty of these issues, you kind of have to use the most precise language possible so that you don't get confused.
And the foundations have to be clear.
Crisp, like it has to be so clear, like not a single word out of.
So easy to get so
It's
confused
so easy.
if you do not lay the foundation.
That's how we started the whole
Yeah.
conversation. I came up to him and said, I came to him with the gripe of the problem with physics and why physics is such a hard discipline, let's call it,
Yeah.
because it's literal. It has to be literal, as opposed to philosophy or telling someone how to live your life. You can kind of be metaphorical. You don't have to watch every single word the same way that you do with physics,
Yeah.
because if in physics you use the wrong word, there's a high chance that they're going to have a different movie in their head than in yours. In physics, you're trying to put the exact same movie in your head into theirs. While in philosophy, you're just kind of trying to get the ballpark. Like if you want someone to lose weight, it doesn't have to be like by the minute exactly how to do it.
More precise.
Yeah, it doesn't have to be that precise. It just has to be, look, just eat less. Less isn't precise. Less to you is different than me. It's kind of all ballpark, kind of metaphor. You can get away with murder. While in physics is so hard when you go
Or
into,
should be. Should be.
Yeah.
Should be precise.
in its I guess purest form, or what we would all like to think of it as its purest form. It's precise. It's literal. It's the literal thing that is really hard. I remember when we were talking about flat Earth one time, and my dad asked how flat is flat. And I just never even thought of that question. Like I just thought, okay, well, we all know what we mean by flat, just a plane or like a board. But then he's saying, okay, then maybe flat. I mean, I think this is what he's trying to get across is then maybe the word flat is the wrong word to use because that's not literal. You're not literally that the universe is that the Earth is two-dimensional because that's flat.
Right.
That is flat.
That is the only flat there is.
Yeah. If as soon as you have a bump, that's not flat anymore. So that's the wrong word.
Flat is two-dimensional.
And that it showed me how easily one thinks and speaks in metaphor. It's just it's so human to think and speak in metaphor that speaking completely literally, it's almost a cartoon. You'd have to make a cartoon character that does that because no one speaks completely literally.
And on that note,
inhuman.
Let me go off on a tangent for a second here. Let me go on a tangent here for a second, and then we'll come back. But we had this word yesterday on which we left at the end of the show, and that was the word touch. And this is just kind of like what he was talking about, flat. How flat is flat? What do we mean by flat? Can we use this word consistently.
How touch is touch now.
Yeah, and we have the same thing with touch. People think that they know what touch means, and so I've heard several definitions out there. This is my definition, okay, and here I'll put it up there. Touch, okay. What is touch? Zero distance. That's what touch means to me. Okay, zero distance. Now they're touching, but we have a problem, a serious problem with that definition.
Uh-oh.
And the enormous problem is that if there's zero distance, they become one object. There are not two objects because now, just visualize this, try to imagine it, you have the table and your finger, you press your finger against the table. As long as there's separation, we have two objects. And you can talk about touch because touch involves two objects. We're talking about distance between objects. We're saying it's zero distance. But if there's zero distance, they become one object. That means your finger became part of the table.
Why do they become the same object?
Well, because now there's no separation. See, for as much as I want to press my finger against the table, I'm not really touching the atoms of there's always a separation between the atoms. They don't merge.
Would you say that the two atoms in my nail are touching?
They're not touching. In fact, quantum will agree with me on this.
They agree with the weird things.
They'll agree with me because they say, surrounding everything is a field. Like that keeps us apart because otherwise, if we get rid of that field, then we would really have touch. And atoms would be touching atoms, but that's not the case. What we have is separation. And again, and that's the problem I have with touch. Touch is an incongruous word because it has its own contradiction, a self-contradiction. It's an oxymoron, in the sense that if you define it as zero distance, you end up with one object, and in order to have touch, you have to have two objects. And so it's a kind of circular.
Oh, I get it now.
It's an oxymoron.
Maybe that's worth saying again.
And why am I raising this? I'm raising this because I always get the question, well, how do the ropes avoid tangling? That's what we're getting at. And I said, well, before they can tangle,
wait,
they must touch.
We're going way too fast.
Okay, we're going fast. Okay, let's go slowly.
Still on the touch zero distance issue,
Yeah,
right?
If we define touch as zero distance, and just an example, if I press my finger as hard as I can against the table, I never touched it.
That's weird.
And I never touched it because there's separation between my finger and the table. And the only way I can touch it is if there's zero distance, meaning that my finger became part of the table. The two surfaces became one surface, a single surface. That means they blended, and I shouldn't be able to pull my finger out.
I think better is how you said it earlier, where it's just a matter of definition. Where if you say you need two objects to touch, right? But an object is that which has shape. Now you have one shape.
One shape.
Because to make
no surface there.
To make the shape of one, you need nothingness at some point to contour that. And as soon as you have two things touching, in the literal sense touching, now there's nothing contouring. There's nothing between them. So the shape becomes the whole thing. But then the question becomes, where do you discern the end of a shape of one thing and the beginning of the shape of another? Because taken to the extreme, you could say there's only one object in the universe and there always will be, and that's the thread. Everything else is not an object.
Yeah, everything else is just made up of
I'm not an object in a way. Because I don't really have shape. It's not me that has shape because I'm a whole bunch of discrete things that aren't touching.
But they're all connected.
The only thing that's touching is the connection, is the thread. So taken to the extreme, you can never talk about objects.
Yeah,
you'd have to talk about. It gets weird.
It gets very weird, and all I'm saying is the word touch is a very touchy definition. A very touchy word, a very touchy term, and it's not easy. And I realized that when I tried to explain tangling. And by the way, it took me 2 years for myself to make sense of that. It kept my book from being published 2 years earlier because I spent 2 years on this issue of tangling. I said, how am I going to explain this?
You mean it took you 2 years to give up?
more or less, I gave up. But
You're hard-headed. That's what you're saying.
yeah. It's a very difficult issue, and that's why I typically don't discuss it on the internet because it's too lengthy to know how I came up with a lot of this stuff. And you'll find this in chapter 7 of the book, Why God Doesn't Exist, in which I go through this process explaining how how we have to explain certain phenomena, like neutron bombardment, why an atom, an object such as a neutron can go right through most of the atom, why it sometimes collides, like, you had Rutherford, and he tried to bombard atoms, and he said, most of them went through, and then suddenly he found out some bounced back from the gold foil. He gave it a bombardment there, and he said, it was like you hold a piece of paper tissue from the bathroom, and you shoot bullets at it, and most of them just go through, just whiz through that, and some of them bounce back. And that's how he explained it, essentially, Rutherford. And yeah, and that's you have to explain not so much the bouncing back. We can all understand when a rock hits the wall and bounces back. We have to explain how the rocks can go through other parts of the wall and go right through it completely. And he says, "I know, I have got the answer. Most of an atom is empty space." And I said, "Well, if we're going to do this with the atom that we have here, in other words, the one made from threads, then you can't say that an atom is mostly empty space. An atom is mostly threads coming from every atom in the universe. But then how does it have this property of being bombarded and going right through it?" And that's when you have to come up with some explanations for those phenomena. You can't just wish them away and say, well, I didn't see that. No, it's there.
Well, we can do it the way everyone else does it.
Yeah. And another one I use as an example, and again, it's, you take a magnet, right? To take a magnet, take two magnets, and you can see that they're attracting each other, right? And you just set them apart and have them held separately. So there's something going on in there. And under the rope model, you have the threads going there. Okay, no problem. And now I point a laser right through the middle of that whole field. And it's not affected. It's not affected at all. The light goes on, it's not deviated. Light is not deviated by gravity like, in quantum and general relativity. So you say, hold it, if you have these threads going around, they're going right through the beam of light, which is ropes extending outwards. How does Mother Nature do that magic? You can't say, well, I didn't see that, I'm not going to explain that. No, you got to explain, you got to confront it. Now you can see why I spent 2 years. It was nerve-wracking. It's one of those things that, you turn around at night, you can't figure out. And so that's why, these are complicated issues. These are not things that you come up with overnight. And one of the things I had to do was come up with the word touch, because if you have these threads going around between two magnets, and you point a laser right through it, which is a bunch of ropes connected to the atoms on the wall farther down. That's what it is. You have ropes going out there, and you have these threads going around it. The first thing you got to explain or define or deal with is touch. You got to say, well, did it touch? Before we cut through it, did it touch it?
Let's go step by step.
Yeah, and then I said, okay, what do we mean by touch? And that's how I got into the issue of touch. And, I said, well, touch is zero distance. But if we have zero distance, they blended and turned into one. And I said, oh, my God. Now I really opened up a can of worms here. And you can see how this train of thought goes. It's not so easy. This is something you really got to sit down and say, well, you got to drink a few beers to understand.
Yeah, it's the definition of touch where then it gets tricky. When you say zero distance, now you go, okay, wait, if you have zero distance between two things, can you call them two different things?
Yeah.
That's the weird thing. Can you call let's take the thread, for example. The thread is an uninterrupted line, you could think of it, right? It's not a series of beads that are touching. it's an uninterrupted line. Can you say that one part of that line is touching another part of that line? No, it's the same thing. You can't really use the word touch when it's the same thing.
But let me give you an example. Let's see if I have it here. I'm going to try to find it. Probably not. I don't know where I have it. But let me give you a good example of touch. I do have an example for touch. You have two objects. We're going to call them hydrogen atom 1 and hydrogen atom 2. Okay? Think of those two balls that we have there. Okay? Let's just think of the red one a hydrogen atom and the blue one another hydrogen atom. Okay? Fine. Now they come together. Okay? And, you know, it's been established, I'm not going to go through all this, but it's been established that if they go in counter, one is going counter in the direction counter to the other, one is going, let's say, clockwise from one point of view and the other one is going counterclockwise, right? They bounce and go off. They do not merge. But if they're both going in the same direction, right, one screws into the other and forms the H2 molecule. And now we have touch, because what has happened, they have merged. One has screwed into the other, the ropes, the threads, I'm sorry. The threads eliminate the rope between them, and they start going, you know, one starts screwing into the other where they merge and they form a figure 8. That's what I wanted to show, the figure 8, but I'll have to find it maybe by tomorrow.
What do we have there?
So you have a figure 8, yeah, but it's more than that. It's like there's a region in between the red and the blue where it's more like a figure 8. This is more like, you know, two zeros.
Yeah.
We're talking about figure 8, where, you know, there's a region there like a Venn diagram. Okay, think of it that way. And now the one part of the surface of the blue one, for example here, has merged with the surface of the other, and they form this region where they overlap. And they form one object. They are touching now, but in the sense that, well, now we're not talking about hydrogen atoms, now they became the hydrogen molecule, H2. And so keep that in mind. That's the way you got to think about these things, because we do have to explain what we have out there. And a lot of these things are already determined. It's not like, you know, oh, we got to reinvent the wheel and all these people did it wrong all these years. Not everything is wrong. I mean, in the sense that the hydrogen molecule is pretty much well established. It's not something I'm going to challenge. I have to explain it, not try to challenge it, because I have to accept that, yeah, this is what they're observing. And I'm saying, can we explain it with a rope model? And I'm saying, yes, we can. And that's where you introduce the word touch, because now you can say, yeah, this atom touched the other one, they merged, they formed a single object, and we're not going to call that hydrogen atom anymore. We have to change its name. Now you can say, well, they touched briefly and then they immediately turn into one object.
In a weird, like, lawyer way of looking at this, we have to not use the word touch.
Yeah.
Because by definition, just the notion is gets completely thrown out the window. It's kind of like a day-to-day notion, a daily notion. What do you use it when you talk about scientific definitions and day-to-day definition? What's the word you use?
And day-to-day?
When you say scientific definitions as opposed to...
we have notions
like common definitions.
Yeah, we have...
I'm just trying to say that...
we use the word notion for ordinary definitions you find in the dictionary, and we'll use the word definition for what we find in science.
But with the notion, with the word, I'm just going to talk about the word of touch. If you define it as zero distance, which I think most people would...
Scientifically.
It gets weird with the rope hypothesis, because there's no such thing as touch, because there's only one object in the universe, and that's the thread, and it's never really... Can you say that the thread touches itself?
Yeah, I guess you could do that, but...
For example, when you get two lasers, and you cross them past each other, can you say that they touched because at some point they were overlapping, that's superimposed?
That's what I was going to say just now, and that is, yeah, if a hydrogen atom merges with the other one, just at that point where they begin to merge, we'll call that touch. Okay, because at that point they just started to have zero distance, if you can say started, to that. It's a cross section of time. At some point, right? They begin to merge and they become one object, which we will call the H2 molecule now. And they continue then touching, you can say, or merging into each other. But the point is, at some point, there's no rope between them. We'll call that the absence of rope. We'll call that touch.
But it gets weird with that because, in a way, you could say that they were touching all along because they're made of the same thread.
Yeah.
In a way, you could say that there are no. It goes to like the Matrix, where they say there is no spoon. There's no such thing as a hydrogen atom here. We just have bundles of ropes.
Yeah.
Of the same thread. Let's go down to the thread level. We have these threads. This one thread. I mean, let's assume this is the only object in the universe, the only thing in the universe.
One hydrogen,
the two balls. Okay. Yeah, forget the letters.
So
the letters
two
are
objects
not,
in the universe.
But it's not. That's the thing. Under the rope hypothesis, assuming these are made of threads, as you claim it to be, or as you assume it to be, then there's only one object that looks like two to us because we give it two different shapes. But when you zoom in, zoom in, zoom in, zoom in, it's one continuous shape.
Yeah.
So you can never say that this atom touched that atom because it's really this bundle of thread has been touching this bundle of thread the whole time. There are no two bundles of thread. There's one bundle of thread.
Yeah, and it becomes complicated with the rope model because there are no objects. We have separated things into objects because that's what we experience every day. We think everything is discrete because, my hand doesn't it's not part of the table. We say, well, the table is a separate object than my hand. But it turns out that, when you take the thread all around the universe, there's only one object. And that is weird under the rope model.
That's a weird way of saying it.
It's a different way of looking at the universe.
It's a weird thing to say there's only one object in the universe.
Yeah.
That's a weird thing to say, but that is the logical conclusion of the assumptions that we established. Right. If we establish the assumptions that we do, then by logic, just going down the series of what do you call them? Trains of thoughts.
Yeah.
There, you have to say there's only one object. We're one object. We're part of the only object in the universe. That's so weird. That goes beyond any Buddhist or meditative stuff because in like going on a small tangent here, in some religions they say we are one with the universe, but it's really there. It's not me and the universe. It's just everything is one thing. And that's so weird. But
because in a way it's true. Yeah, we're one with the universe.
And going back to the word touch, that's why you can't really use the word touch, at least in your use of the word. In your you have no need for the word because everything is one. You can't say that one chunk of the thread touched another chunk of the thread. That's kind of clunky.
Because they kind of blend also. Again, if you look at any of the elements, just take any element from the periodic table. What are those elements? Well, if you take hydrogen, you take 4 of them, you make helium. Why do you make helium? Because the standard hydrogen is a proton, and we'll call it a dandelion, right? We have this little sea urchin in the center with all the rays pulling out to every atom in the universe, and you have the electron shell covering it, right? That's where we start. But now, in order to make a helium atom, or helium element, you need 4. You need 2 protons and 2 neutrons. And what is a hydrogen atom? It's, in a way, a neutron. It's got the same weight and same mass, right? And that's because it's just a different configuration of an atom. That's what a neutron is, a free neutron. And so you're going to need 2 neutrons, you're going to need 2 protons, you're going to need 2 electrons. It means 2 shells, 2 S shells. The one shell contains the other one. One encapsulates the other one. That's what a helium atom looks like in reality. And that's not only from me, that if you do some chemistry research out there, you'll find that that's the way they illustrate it, in chemistry today. They just call them orbitals, and I'm saying there's no such thing as an orbital. What we're looking at is a shell encapsulating shell. But my point is that you need 2 neutrons, 2 protons, and 2 electron shells. In other words, you need 4 hydrogen atoms in order to make a helium atom, and that's done in the center of the sun. It crushes 4 atoms and turns them into helium. Hydrogen atoms turns them into helium.
Let me see if I got that right real
Yeah.
quick. So to make a helium atom, you need 4 pairs of plus and minus proton and proton and electron. Is that right?
You need no, hold it. Let's make sure we understand that. You take 4 hydrogen atoms, right?
Yeah. Which
which is just a proton and an electron shell, right? So you got a proton dandelion or proton sea urchin, and it's encapsulated by an electron shell or balloon. Okay? You take 4 of those, and you're going to build a helium atom. You're going to crush them together, which means that all these shells are going to merge. You're going to have a bigger atom, right? So the 4 electron shells make this bigger volume. That's all it does. And what does it encapsulate? It encapsulates 4, you can say 4 protons, but 2 of them are threads, 2 of them are crisscrossing of ropes. So you have, that's the neutron. The neutron, 2.
What's a neutron?
Neutron is the convergence of ropes. And that's what we're going to say is a neutron inside the helium atom, right? And on the other hand, you have 2 protons. But since the since the neutrons in there have not opened up to become the electron shell, it's the piece of thread that would otherwise make the electron shell is going together as a rope towards the center, which is the neutron. I'd have to draw it because a picture's worth
I was going to say
words.
that we're using language to describe an atom.
Yeah, it's
under the
easier
rope hypothesis
to look at the picture, and all I'm saying is you have 2 neutrons in there, which are convergence of ropes, and you have 2 protons, which are convergence of threads. Those 2 are different. And the reason, you can take and you say, well, what happened to the 4 electrons? We only have 2 electron shells. And I'm saying that the rope necessary to make the electron shell is really going in there and making the ropes of the neutron. It's still in the neutron. It hasn't become part of the shell. And again, the picture's worth 1,000 words. My point is you need 4 hydrogen atoms to make a helium atom. From there on, all you need is 1 more hydrogen every time. You want to make lithium, just add another hydrogen atom. And again, when you look at all these, if you look at the orbital structure, which is essentially what the rope model, goes with, because we're just saying the orbitals, we're going to replace them with threads and with balloons. And all you need to do is just add 1 more hydrogen atom as you go along. So you're saying, well, how do you add another hydrogen atom? Well, that's done in the sun through pressure, but what is the sun doing? It's merging another hydrogen into this little balloon. That's what it's doing. So the proton from the hydrogen atom goes to the center, and the electron goes to build up the shell. And the bigger it is, it encapsulates a new neutron. And again, I've got a video on showing how this builds up a little bit, okay? So all I can say is, it is rational. Mother Nature is rational.
Yeah, but
there is a way of explaining what she's doing. It's not. If you don't use math, you're gonna be okay.
But this was a series of extremely complicated interactions of one continuous thread.
Yeah.
That's the weird thing.
Ultimately, that's what it is.
It's like you can't build a computer that can calculate, that can even simulate this. I mean, you could on just one simulation, but you can't simulate the whole universe for sure.
You're talking. I'm trying to create a molecule here that I'm going to need for my presentation in Argentina, and just that little molecule, it just blew me away.
Just one. Forget the interaction of molecules. Just one molecule, and exactly where which thread goes. Forget all the where all the ropes come in, because if one atom is connected to every other atom in the universe, right? you can't even draw.
No.
Literally, you can't accurately draw. There isn't enough ink in the world to draw one atom. Precisely.
Yeah, you're talking about gazillions of
There's,
threads coming
it's
in.
it's almost unimaginable. I mean, it's imaginable, but like the simplified version is imaginable in my head. I can imagine a sea urchin, but it's weirder than a sea urchin because there's no. You have to zoom in and zoom in and zoom in.
Yeah, but
to see
let me give you a little piece of information there, and it's an important. Keep this in mind. This comes from Richard Feynman, a guy who did quantum mechanics, and he says the following. I can't remember the exact number, but he said the ratio between gravity and electromagnetism is in the, I think he said 10 to the 46. He says that's an enormous number. Where does this enormous number come from?
what's that in relation?
Well, it's like saying if you have under the rope model, consider the rope model, gravity ropes from every atom that's from this object that has all these atoms that's coming towards you, it's accelerating towards the earth, whatever, an asteroid. So you have the ropes. What is electromagnetism? Well, it's at the local, in a local scenario, okay? That's localized. And you're saying, if you're talking about an atom, which is what electromagnetism relates to, the charge on the electron, that's what he was referring to. And you're saying, well, hold it, the charge on an electron, which is all these threads moving around on an atom, and the ratio to gravity, there's a 10 to the 46, I think that was the number he used, ratio between gravity and the charge on an electron. He says, where do all these numbers come from? Where does this big number come from? And I'm saying, he got it, assuming that number is correct. I'm not even sure the numbers are correct, but now we can answer that question. We say, yeah, there is, because all these threads are coming and all these ropes are coming from every atom in the universe. And maybe that way we can figure out,
how many
atoms there are. But I'm saying you can't from that number, because that's really a ballpark number, first of all. Second, he's talking about a ratio. And in the case of threads, we have to be and ropes also, we have to be very careful because they do superimpose. And so from that, it just takes out a lot of information from there to try to determine how many atoms there are in the universe.
What is there to say about this complete dynamic shift in your mind when you try to adopt this idea? Just the basic assumption of all atoms are connected, right? All atoms are connected in the universe.
Yeah.
If just that one assumption, that's just one assumption. From that one assumption, you lead to so many different ways of looking. I mean, not different ways of looking at the universe, but different conclusions. The logic from that assumption gets so weird, so not
traditional,
human. Yeah, so not what we've seen on Earth. It gets so weird. So, what do you have to say about
it blows you away,
changing your universe view? It's not a world view; it's a universe view. That much. No one thinks about the universe in these terms as one continuous thread.
Yeah.
Does it have something to do with our common sense? Like, this is so non-commonsensical.
Maybe you could say non-intuitive, yeah.
Yeah, it's non-intuitive, but not in the I can't imagine it way. It's not that kind of non-intuitive. I can imagine it, I can visualize it.
It's just totally different.
But it's just so different than what you'd expect.
Yeah.
That it changes your conclusions on so many things. Did it change any way? Like, how did that change the way you saw the universe?
Oh, completely. I mean, once you start, pulling on that little thread and go into this labyrinth.
If you just take that from that first assumption.
Yeah, then you can't find your way out.
Yeah.
It's a good thing I took the little thread, that
yeah, good thing it's all connected.
To see the the Minotaur in there, and once you see him, you say, oh my God, I want to get out of here, because it really is crazy. It just gives you a different way of looking at the universe. And it kind of also relates to, again, Buddhism, I think Hinduism as well. They look at it and they say, be one with the universe. And in a way, they've always been right. In
But
that sense, that it's all these discrete particles. That's not one with the universe. That's quantum. But if you now start uniting or binding or interconnecting the whole every atom in the universe, now we are one with the universe. Especially if you have a single thread, closed loop thread, and it just tangles in so many ways to create all these atoms, neutrons,
and
and
effects that
matter.
we see. But going back to how we started this with physics being literal, in the religious sense, they say we are one with the universe, as in you can kind of feel the universe. But when you talk about physics, we are literally all one thing. That's such a weird. No one. I mean, when someone says we're connected, it's always meant metaphorical.
Yeah, no
Unless
physical.
we're Siamese twins, no one ever means we're connected in that sense. Like we're connected. Yeah, I'm connected to my dad. I call him on the phone every now and then.
Or we're connected spiritually.
Spiritually, or with a relation.
And now we're saying we're connected
but
physically.
That we're all one thing is so weird. It changes. It changes everything.
Yeah, it
just
does.
just one little assumption. All atoms are connected.
Yeah.
I mean, obviously you have to establish what an atom is,
And
but we kind of
justify it. But I mean, just making that assumption, everything is interconnected. It's just mind blowing.
I guess the more accurate or precise way of phrasing it is the universe is one continuous thread. That's the more precise. Instead of saying we're all connected, because there's no me, there's no you in the literal sense.
Yeah.
The literal sense is just one really long thread that likes to play games with itself.
And that's Mother Nature. Mother Nature, or Father Universe, any way you want to say, God maybe, it's made out of one thread. That's God, one thread, a closed loop thread. But there's another issue, and we have to keep that in mind, because people might say, well, is that really true? Is that has that been proven? Is there a way to verify? All this other stuff. And again, the only way we can see this is with the mind. And
this is a logical conclusion.
First of all, it's you could say that, but this is what I'm trying to get at. If you want to explain gravity, you're explaining two objects. You're saying, okay, we have the Earth and the Sun, or we have the Earth and an asteroid, whatever. You just take any set of two objects. How do we influence that object? I mean, there's only one way. And that's you got to put a physical object in between, a mediator. And a lot of people say, well, no, I don't want to put a mediator in there. I'd rather work with spirits, energy, mass. No.
Well, let's give Mother Nature the benefit of the doubt and say there is something there. And assuming there is something there,
then it's got to be an elongated mediator. There's no other way you can avoid it. So either we don't have something in between the asteroid and the Earth. We don't have anything between Halley's Comet and the Earth, or Halley's Comet and the Sun. It just goes around for no reason whatsoever. Or Halley's Comet is bound, physically bound to the Sun.
Or more literally speaking, it is the same thing. They're both the same object.
And the Sun, here I have my little, and the Sun twirls Halley's Comet around like that.
Yeah.
And there's got to be some elongated mediator, okay? And if we don't have that elongated mediator, we're doing it with magic. We're doing it with nothing here. We're doing it with spirits. We're doing it with energy. We're doing it with math. We're doing it with mathematics. Here we're doing it with physics. That's the difference. Here there is a physical object that's connecting it. So if you're going to put a physical object, now you have to justify it. You got to say, well, what is that physical object? And at that point, you have to come to the conclusion, I think it's the only conclusion, that there's got to be a rope connecting every atom. And that also explains why gravity goes through things. You put a wall, and gravity goes through the wall and also attracts the wall itself, every atom of the wall. So, you put a shield here. I'm going to create an anti-gravity shield. I'm going to bring my anti-gravity shield, and gravity pulls on your shield and you and everything else. And I try to protect myself. I can't protect myself from gravity. No, because it's every atom connected to that other thing that's pulling on every atom. And the only way I can do it is if every atom over there is connected to every single atom here, right through your shield, including your shield. Every atom that comprises your shield.
Your shield is pulling on you.
Yeah. So it's a totally different universe. You don't do it with math. You do it with physics.
Okay, but given that it's a completely different universe, I mean, we're still in the same universe, but the way we look at it, the
Sometimes I don't
explanation,
know. I don't know if we're in the same universe.
our explanation for all this is so extraterrestrial. Do we have to change our entire language to accommodate this one assumption? Because even you're using your language incorrectly in a way when you say Halley's Comet is an object and the sun is an object.
Uh-huh.
Really, if we're speaking like the robot, the entire thing is one object.
Unless you tell the computer or the robot or whatever,
For
disregard the rope.
Yeah. For the time being,
For the time being,
yeah.
every time you see the rope, just disregard it and consider anything on the other side a different atom.
But we do that
and then it understands.
Yeah,
but if you include the rope, yeah.
But that part, but we only do that shorthand of considering you and I two separate objects as two different shapes, kind of just to speak among humans. But that's what I'm saying. Maybe we have to change our entire language to accommodate that assumption that the whole universe is one thread, because it gets really weird. If you were to pit two robots talking about science, and they started with this assumption, you'd get a weird conversation that's perfectly logical. It's exactly how Mother Nature runs her shop, assuming that assumption is correct. But when if a stenographer, or if you saw a record of what the two robots talked about, you'd get some weird link. You'd be like, what are they talking about?
There's another way to
get weird.
There's a different way of visualizing or conceptualizing what you're saying. How would you program the computer? Now this is where we got to go. How would you program a computer to deal with these subjects? Like if everything's interconnected, right? And then you have to explain phenomena like, well, how does gravity work? How does light work? How does an atom work? How does electricity work? How would you program the computer so that it makes no faults and is able to carry out all your instructions? And that's where you come up with, that's where you're going to really run into a lot of trouble, because the computer's just going to do whatever you put in, garbage out. That's what you're going to get. And so now if you put the rope, right, in there,
the thread,
or the thread, you can work at any level. You have to tell it you got to say, look, I have the sun and I have Halley's Comet, and then the computer says, no, you have only one object.
Yeah.
And you have to say, well, R2D2, please disregard
the
rope. You gotta program that.
No, you don't. That's the thing. You don't. That's my whole point. When you have two robots talking to each other, they don't have to do that weird Halley's Comet is one object, the sun is another.
Why not?
Because that's only shorthand so that we can understand it with our puny brains. That's literally what that is. With robots, they just go off the thread, and they can literally explain everything with just the thread. They don't have to speak in terms of Halley's Comet anymore. That's the weird thing. If you saw the record of the two robots, hold on.
You got to give a name to Halley's Comet so that
true. But you're just naming a clump, a ball of yarn.
Yeah.
But it's not an object. You can't call that an object because you already established that the only object is this thread. So it would recognize the clump as Halley's Comet and this clump as the sun, but it wouldn't recognize them as two objects. And what I'm saying with that is, if you put in all the assumptions that you and definitions that you espouse or put forth, recommend, whatever you want to say, if you saw the record of the two robots talking, you'd get some very eye-opening conversation. You'd be like, wow.
Because the robot,
I bet you'd learn a lot.
The computer would have to talk about balls of yarn or clumps of atoms and ropes, because even the atoms within an object like within you are connected. So there's ropes in there, and you can't separate the rope from you, and there's thread going all around you, and so I guess in a sense the computer or the robot would have to somehow understand that you're one clump, and here's another clump called a table, and here's another clump called a tree or whatever, a rock, and somehow has to distinguish the clumps, the balls of yarn over there.
But only so that we could understand what it's saying. They could understand each other fine, but for us to understand what he's saying, what's this clump? Oh, that is what you call Halley's Comet. It's kind of like the Matrix, where it sees how the fundamental building block of the universe interplays with itself, and we have to kind of suffice ourselves with just calling it you, me, Haley's comet. Yeah, we got to kind of do these shorthand things because we can't go we can't every time you say a hydrogen atom, you're implicitly, I mean, even explicitly, you're not only isolating it, but you're calling forth the exact image. If you had to say, if you're talking to a robot and you said hydrogen atom, it would have to imagine the exact thing you're saying. One atom connected to every other atom in the universe, so it would actually have to have accurately how many threads are in that sea urchin. It would have to get that all to a T, and it would just get weird when you're talking about a group of atoms. It would think of it in a different way than we do. So the question always comes back: do we have to change our entire language and perception of the universe to accommodate this one assumption?
For sure.
The whole language would be weird. I mean, in a way, you can't even use the word object because there is only one object.
Yeah, object is also a I mean, when we're trying to explain ordinary phenomena,
Yeah.
and by ordinary, I'm even referring to extraordinary stuff we can't see. I mean, as long as we did classical mechanics and we tried to explain everyday things, we had no problem. We could see them, we could hear them, we could smell them, whatever. But then we had problems with all these other things that we couldn't see. We said, well, what is light? What is magnetism? What is electricity? We started going into all these invisible things, air included, because we had to figure out air also. What is this air? Is this phlogiston that they came up with in the 17th or so century? And so, we had to invent words for it. And we said, well, what is this thing that's coming out of my mouth? What am I blowing out? And so we ran into trouble with the invisible stuff. And so now we went to extraordinary physics. Now we had to explain the ordinary part we left behind. We said, now let's explain the extraordinary stuff.
We have ordinary invisible stuff, and then we get the extraordinary physical stuff, invisible stuff.
But now we go into a different region where we get rid of all these concepts that they invented: energy, mass, time, etc. And we say, okay, let's see how Mother Nature actually runs her shop. And we go in there and say, okay, let's make some assumptions. And we say, okay, let's assume every atom is interconnected by ropes, and those ropes are the same thing that constitute the atoms. In other words, they construct the atom. And now it gets really weird, because now we end up with a different kind of universe where everything is interconnected, but it turns out there is no such thing as everything. Yeah. There's only one thing. There's no everything. It's God. One thing.
That is God. You're saying you've seen God, and God is just a ribbon.
It's just one thread.
Just one
closed loop thread. That's God.
Just playing with itself, essentially.
Yeah, and that kind of pushes God out. I mean, the God of the Bible. Like he's outside of this thread. No, I don't think so. You can say, well, God made the thread. Well, is he connected to us? Is he connected to the thread? Is he part of the thread?
Dang, it's weird.
Anyways, I guess with that, we're going to call it a day. We're going to see you tomorrow, same time, same station. And maybe we'll continue with touch. I don't know. I don't think we touched everything that needs to be touched with touch. In general terms, I guess you get the picture, and I think maybe we don't need to go any further than that. That's essentially to summarize here. Touch, zero distance, but zero distance converts two objects into one. You can no longer talk about touch, but the only thing you can say is that the two objects became one. Example, the hydrogen molecule, H2. And so it's no longer two H's, but it's H2. So, if you look at chemistry, you have two H's, or you can say H plus H equals H sub 2, subscript 2. And subscript H, the subscript 2H, is different than H plus H in that sense. It's a different configuration. And with that, again, we'll see you tomorrow, same time, same station. Bye-bye.